So let's introduce the Bellman-Ford algorithm. So how does it work? Initially, it would overestimate the distance from the source node to all other nodes, but they will repeatedly visit all of the edge and relax and estimate to new shorter path is discovered in each iteration. And when the iteration is not updated, we can stop. So this algorithm would iterate at most n minus 1 times. So if this graph has negative cycle, we can check it in number of n, n times iteration. And when the distance estimate is modified, it means that it will not have solution to the shortest path. So why iterate n minus 1 times? So because this algorithm would iterate all of the edge in any orders, and we have to visit and relax at every iteration. So we may get optimize the result after less than n minus 1, but at most n minus 1 time. So this part is for the graph without negative weight cycle. So this part is with negative weight circle. So how do we check whether we have this negative weight circle? We have to check one more time. That is, we have to check v times. V is the number of vertex. So let's start. So the iteration 1 is 0 to 1 and 0 to 3. So it will have 2 and 6. And then 1, 2, 3. 1, 2, 3, it is 2 plus 1. So we have to update to 3. And then 3 to 1. Oh, sorry. 2 to 1. Because it is infinity plus 13, so we don't have to update anything. So 3 to 1. 3 to 1 is 3 minus 3 is 0. So at this time we have to update it. It is 0. And 3 minus 7 is negative 4. So this is negative 4. So this is our iteration 1. And then iteration 2. So iteration 2 is remain 0 and 3. So 1, 2, 3 is because here is 0, right? So 0 plus 1 is 1. So we update 3. Here is 1. So 2 to 1. So negative 4 plus 13. So the 0 is more smaller. So we don't update anything. So 3 to 1. 3 to 1 is negative 2. So we update to negative 2. And 3 to 2. 3 to 2 is negative 6. So the step 1 is we set the distance to the source node itself to 0, and all other distance is infinity. So we will check all of the edge and relax them in each iteration. And the step 3 is If an iteration does not have an update, we will stop the algorithm. And at most, we would iterate for a minus one time. So how could we not possible to find the shortest path with the negative cycles? Because when negative wave cycle is exceeded, every iteration of the cycle can give a shorter path. So how do we detect? After we complete at most a minus one iterations, we can perform the n iteration. If any distance estimate is updated, that means we detect a negative wave cycle. So this is the step one. Set the distance to the source node itself to zero to and other nodes to infinity. And step two is check old age and relax. Step three until the minus one are complete. And step four is most special. It is different from the without negative cycle. So we will perform additional one time to detect if a negative cycle is present in the graph. So the code implementation is V multiple E and space is OV. So this example is with negative weight cycle. So in this example, we will have to check another iteration. For this case, we have to check 3 plus 1 times. So 1 to 3 is 5. 1 to 2 is 4. 3 to 2 is 9. But 4 is less than 9. So 2 to 4 is 11. And 4 to 3. 11 minus 15 is negative 4. So the first iteration done. So 1 to 3 again. 0 to 5, no update. 1 to 2, no update. 3 to 2, negative 4 plus 7 is 3. And 2 to 4, 2 to 4 is 10. And 4 to 3, 10 minus 15 is negative 5. So done. So the third iteration, 1 to 3 is 3. 1 to 5 is negative 5. 1 to 2 is 3. 3 to 2. 3 to 2 is negative 5 plus 7 is 2. And 2 to 4 is 9. And 4 to 3 is 9 plus minus 15 is negative 6. So based on the algorithm, in this third iteration, we have to get the final answer. So based on the algorithm, we cannot update any distance from this graph because we will get the final answer at this iteration. So let me see the 4 iteration. What we got? So 1 to 5, negative 6. 1 to 2 is 2. And 3 to 2 is negative 6 plus 7. So it's 1. So that is we update at the 4th iteration. So this algorithm failed. So this is coding part. And our logic is We will have to test the graph without negative cycle and graph with negative cycle. And and how we detect the presence of negative weight cycle? Because we can detect it from n nth iteration. If one of distant estimate is modified, that means the negative weight cycle existed. Therefore, there's no solution to this. So we would decide a Bellman Bellman-Ford algorithm, and in this main function, we would execute for n minus 1 times, and then we will have an if statement and iterate n times number of n iteration, and if it returns true, it means that we detect a negative weight cycle. So the logic is that. So we have to new distance array, and this next size for and then oh, so the distance of start is 0. So we have to execute for n minus 1 time. So if not, this is mm, the Bellman-Ford algorithm works. And if it don't update, we will stop the iteration. Okay. Yeah. So if it don't update, it means that we can stop it. So just return our answer. Then after this, we have to check about our algorithm is works or not. So we have to check another time. If it is not true, we can continually recur our distance. Okay, this is the logic. And so this is Bellman-Ford. So we use a goal, we use the update to get whether it is true or not. So if it is true, we would enter this, right? So if it is not updated, we can end of this algorithm. So for the current, and age. Okay, so I think it might be okay for index. It is current nodes, index, and age. Great. Good. Then, so we have to get access for our neighbor and its weight. Weight. Okay, so this is age. Okay, so the new distance equals distance around index plus neighbor's weight. So if this new distance is less than current neighbor's weight, and we have to update, right? So don't forget we have this means that we update successfully and get the new minimum distance. So when we got this, we can directly return what we update or not. So yeah, I think it is the answer. So if if it has if it has the oh, sorry about that. So in this one, we end of the iteration 2. So we stop the algorithm and we get the short distance is 0 to -4 and 3. And this one, because we detect another update, the distance estimate is modified, so we cannot have a solution for this new data because this is an additional negative. So if this is positive, we can get the final answer. Okay. So let me compare the Bellman-Ford algorithm and Dijkstra algorithm. So the Bellman-Ford can only apply to an undirected graph with negative 8 weights for finding the shortest path. So the Dijkstra algorithm is more efficient, but it cannot handle the negative